Radiological terrorism is a real problem. There are radiation sources that are lost all the time. You occasionally hear about sources that are stolen, and we know that there are bad people out there that would like to do us harm. So to protect us against incidents like this, there are multiple agencies in the government and all the way down to your local firemen and their hazardous materials units around the country that are standing ready to either interdict people attempting to do this or respond to it in the event that something bad does happen. Part of the problem is that radioactivity and radiation is invisible, and it's very difficult to find without having special instrumentation to do it. So these people who are charged with saving us and protecting us, their first job is to catch it before it comes in and find it. They have to have special instrumentation to do that, and they have to be trained to use that instrumentation. It's not possible for them to train right now in a way that will use the real instrumentation we want them to be prepared to use against these high hazard situations that we'd like them to be prepared to deal with. We've come up with a solution to solve this problem in training, and we've done it in a way that allows them to avoid all of the expense of dealing with real radioactivity and all the security issues that come along with that.
So what we have here is what we call the Radiation Field Training Simulator, or RaFTS, designed to provide realistic training to folks that are searching for illicit radioactive materials.
And it combines the best of what can be done in the real world with everything you can imagine in the computer world into a single device that allows the responders to use their real operating instrumentation against these sorts of scenarios we want them to be prepared to deal with.
Doing that makes it so that we can simulate radioactive sources in the field without bringing any hazardous material to the field at all. This board and this board are what we're talking about that shrink down into this box. Unplug the detector from the preamp and plug in the RaFTS input. So the first thing we come upon is a point source of plutonium-239, which it detected and identified pretty quickly. Then even before we got to the hottest area of the uranium, we stopped and were able to identify it. It quickly went from U-235 to enriched uranium to HEU, highly enriched uranium. Then we moved on to the simulated plume of cesium, where the light colored is the detection level, the darker is kind of the medium, and then the hottest zone of cesium contamination. And again, the key here is this is something that no other training tool allows you to do, and that's see a wide area ground deposition of a contaminant.
So the plans going forward are to demonstrate this on other detector types. We've done one, as I said already, and we're working on a second. In addition to that, we're trying to get the capability standardized across the community so that 5 or 10 years from now, every single instrument that is purchased or produced will have the ability to accept inputs from a device such as RaFTS.